Assalamualaikum and a very good day class. So some of you have a problem on chapter 5. In chapter 5 we have two topics here. The first one is solving. We need to solve, that is solving ODE, boundary value problem, by using two methods. The first one is shooting method and the second one is finite difference method. I will show you example how to solve ODE, which is in terms of boundary value problem by using these two methods. So first we start with this shooting method. In shooting method, we have here 5 steps. The first step, class, you need to reduce second order ODE to a system of first order ODE. What does it mean here? Okay, in the problem of shooting method, you will have differential equation in terms of second derivative of y respect to x. Okay, you will have this one with boundary value problem. That is, for example, we have y naught, and also we have the value of y at time tn. Is that at the last time here? For example, y naught equal to 0, y at the last time t equal to, for example, yn. And then here, when we want to reduce to second order, this second order ODE to a system of first order, means that you need to reduce this second derivative to a system of two equations. That is, we have dy dx and also dz dx. This is the first step. And then step number 2, once you have reduced to a second order ODE to a system of first order ODE, you need to determine initial value. Initial value here means that you need to determine the value of, see, we have 3 variables, x, y, and z. That is, x is independent variable, y and z is dependent variable. Means that we need to find or determine initial value of x naught, y naught, and z naught. But class, x naught and y naught already given in the question, because here if you have dy dx, so this is your initial value, which is, for example, this one, y naught equal to 0 and x naught equal to 0. This is just example. But the problem is, what is the value of z naught? In this case, z naught will be given in the question, because actually you need for this syllabus, z naught will be given in the question. And number 3, class, once you have your initial value, you need to solve dy dx and also dz dx by using x naught, y naught, and z naught. And how to solve this one? You can use Euler method in chapter 4. Okay, and then when you solve this one, step number 4, you need to check the solution obtained at the last point. For example, we have here the boundary value, so this is the last point. You need to check the solution of y that we approximate based on this Euler method. Okay, for example, this is y Euler method at time tn. Is it equal to the boundary value given in the question? Is it equal to this y tn? For example, this y tn equal to 10. Is it what you got here? Okay, it is equal to 10. This is just for example. If it is not equal, means that the z naught that we guess here, it is not correct. Okay, when it is not correct, number 5, we need to find a new, means that still at number 4, we need to find here or guess here a new z naught. So, for example, this is z naught equal to 1. This is just example, class. Let's say when it is not equal, you find x naught, y naught is based on the question, but z naught now you assume equal to -1. So once you assume this one, again you need to solve. Okay, step number 5, we need to solve dy dx, dz dx based on our x naught, y naught, and our new z naught equal to -1. Okay, and once we solve, we need to compare again. And is it this y that we solve using Euler method at last time equal to y in this question? For example, is it equal to 10? If it is not equal to 10, means that this z not, actually it is not correct. The next step, class, we need to extrapolate the value of z0 by using the formula z0 equal to g1 plus g2 minus g1 divided by r2 minus r1 and d minus r1. What does it mean by all this? Okay, g1 refer to the first guess at initial slope. The first guess means that here z0 that is equal to 1. Okay, this is the first guess of our z0. And G2 refer to the second guess of z0 that is based on previous example I give -1. And D is the desired value. For example, our y Tn equal to 10. And then R2 is what we compute at endpoint using this G1. Means that y Euler method Tn by using z0 equal to 1. And z0 equal to -1. This is R2. So it is using the second z0. And then R1 here means that y that we approximate using Euler method at endpoint by using z0 equal to 1. So this is just example. Okay, means that this is step how we can solve using shooting method. But class not yet finished. Once you got the z0, step number 7, again you need to solve your dy dx, dz dx, and then by using your new x0, y0, and z0 that we extrapolate based on this step 6. So once we solve this one, again you need to compare, is it y using Euler method at this, by using this step, is it equal to the endpoint of boundary value given in the question, or is it equal to 10 in this example? It should be equal to 10. If not equal to 10, there is something problem in your calculation. So class, this is basically the idea how we can solve using shooting method. So here I go to the example which is in your module, example 5.1. I repeat this example taught by by Miss Fatiha, because this is just simple example so that you can get the idea. Use shooting method to approximate the solution of boundary value problem given to us y double prime x minus 2yx equal to 0. This is function class. Okay, that is our y0 equal to 1.2, y 1.0 equal to 0.9, and we have here h equal to 0.25. So, what we have here from the question, you have second order ODE with this boundary value and also given to a step size. And for step number 1, okay, in this case we have actually y prime minus 2y equal to 0. And based on this one, this is a value of x0, which is our x0 equal to 0, y0 equal to, this is y0, which is equal to 1.2. And then class, we have here the last time, which is the last time for this example is 1. That is, the boundary is given by 0.9. So if I draw a straight line here, I start with this x0 0, with this increment of the step size 0.25. So I will have 0.25, 0.5, and then 0.75. That is the difference here is 0.25, 0.25, 0.25, and the last one should be 1.0. And then this is y at 0, which is equal to 1.2. And then the last one is y, value of 1.0 given in the question 0.9. 9. And this is our x0, this is our x1, x2, x3, and also x4. So here, I can write this one is y0, and you will find here y1, y2, y3, and the last one is y4 by using shooting method. Step number 1 class. If you still remember, you need to reduce this second order ODE to a system of first order. We have here y double prime minus 2y equal to 0. When I reduce this one into a system of 2 ODE, I need to let, okay class, I need to let z equal to dy dx. This one you have to always you have means that you need to always write like this. Means that always the first step you need to assume z equal to dy dx. Means that if you have your y in terms of your dependent variable, okay, and then x in terms of your independent variable, so always you need to let z or z equal to dy dx. And then when I differentiate this z, I will have dz dx equal to, I need to differentiate also this side. There is second derivative of y respect to x. Here class, we will have, if I write again, I have dy dx. I write this one, it is equal to this z. Okay, but I want to have a system of first order ODE. Means that I need to have here dy dx, and then I write this one as another equation, that is dz dx. It is equal to second derivative of y respect to x. Second derivative of y respect to x, you can get it from question. That is, if I write this question in terms of this one, I will have second derivative of y respect to x equal to 2y. And this one, same with this one, right? When I substitute second derivative of y here in this function, I will have my dz dx equal to 2y. And then class, based on the question, we know x naught equal to 0. Okay, this one, x naught equal to 0. And y naught equal to 1.2. And then, for this one, for this dz dx, we know x naught should be also equal to 0. But what is the value of z naught? In this case, in step number 2, you need to determine the initial value. So class, in this question, does not mention the value of z naught. Actually, this z naught, you can guess any value. And I follow this example. In this example, this z naught is choose to be equal to negative 1.5. You can choose actually any value, but when you choose any value, if it is not the actual z naught, you need to do extrapolation. Okay? So once we got this system, what we need to do class, we go to step number 3. We need to approximate the solution by using Euler method. Okay? The solution by using Euler method. So we recall back, we have a problem of dy dx equal to z, and then we have dz dx equal to 2y. We have x naught equal to 0, y naught equal to 1.2, and our z naught equal to negative 1.5. So now how can we approximate this one by using Euler method? You have to refer back to the chapter 4, which is solving system of equation by using Euler method. The first step, using chapter 4, you need to let f1, x, y, z. f1, x, y, z means that function number 1. We have two equations here. This one is the first equation, but you see the unknown here, x, y, and z. We are this one equal to z. Function number 2 of x, y, and z means that this one is dz dx, which is equal to 2y. And then by using Euler method is iterative method. We need to start here with I equal to 0. When I equal to 0, we have x naught equal to 0, y naught equal to 1.2, and z naught equal to negative 1.5. So class, we need to solve this one to find here. The first one, we need to base on the first equation, F1. That is, when we solve for x1, we want to find y I plus 1. I write the formula of Euler method here. Yi plus 1 equal to yi plus h f1 xi yi zi. And then zi plus 1 equal to zi plus h f2 xi yi zi. So class, when I equal to 0 here, this yi plus 1 means that 0 plus 1, you will compute here y1 by using yi, I0, so y naught plus h f1, and in this bracket I, so also x naught, y naught, z naught. That is, y naught is given by, from here, 1.2 plus h is given in the question, h equal to 0.25. The 0.25 multiplied by the first function. The first function is z. So here z naught means that multiplied by z naught. So equal to 1.2 plus 0.25 multiplied by negative 1.5, because our z naught is negative 1.5. When we solve this one class, we'll got the answer here equal to negative 0.9. And then once we got y1, we need to solve for z1 by using this formula. z1 equal to z naught plus h f2 x naught y naught z naught. So in this case, z naught is given by negative 1.5, means that negative 1.5 plus 0.25, and then now we are referring to the second equation. Second equation is given by 2y, means that here 2 times, because this is second equation. And f2 here, x naught, y naught, z naught means that 0, 1.2 and negative 1.5. But function is 2y. So 2 times y naught. 2 times 1.2. When you solve this one class, you will got the answer equal to 0.8250. And then next, we need to find x1, which is x1 here equal to x naught plus h. That is, x naught is 0 plus 0.25. So it is equal to 0.25. What we did previously, class, is for first iteration. If we go to the second iteration, that is now our I equal to 1. Based on previous solution, we have x1 equal to 0.25, and then we have our y1 equal to 0.825, and z1 equal to negative 0.9. Now we want to find our y2 and also z2 and x2. So y2 based on Euler formula equal to y1 plus h function of x1, that is function number 1, y1 and z1. So this one, y1 is 0.825, means that 0.825 plus h is, our h from question is 0.25. So plus 0.25 multiplied by the first function. The first function f1 is given by z. Means that here we need to substitute with z1, which is negative 0.9. When you solve this one class, you will got the answer equal to 0.6. And then for z2 here, Z2, how to solve for Z2? We use Euler formula. It is Z1 plus H, F2, X2, Y2, and here X1, Y1, and Z1. That is function number 2. Whereas here our Z1 is given by this negative 0.9 and plus H 0.25, but function number 2, if you refer to previous slide, it is 2y, means that 2 need to multiply by y1, that is multiply by 0.825, so we'll got the answer here equal to 0.6. Equal to negative 0.4875. And then x2 will be equal to our x1 plus h. That is 0.25 plus 0.25, you got 0.5. Means that this one, what we solve here, we got the value of x not already given in the question. We already got x1 equal to 0.25 and y1 we got equal to 0.825. And then x2 we got equal to 0.5 and y2 equal to here 0.6. And then you need to find x3, y3, x4, y4. Here, how to compute our x3, y3, x4, and y4? Why it is up to x4? Because if you refer back to the previous slide, our last point is here x3 we know 0.75 and the last point is x4 1.0. So this is the last point of x, means that you need to find up to y4. So you have to repeat class the same process. That is, we need to increase our I. Instead of previous I equal to 1, now I equal to 2. And the solution for I equal to 2, that is y2, z2, x2, we already get from this calculation. That is our y2 equal to 0.6, our z2 equal to negative 0.487, and then our x2 equal to 0.5. When we solve this one, we need to find our y3, z3, and x3 by using the same process but use this updated value. So y3 you will got equal to here 0.4781, z3 equal to negative 0.1875, and x3 you will got this one, okay, which is 0.75. And then class, this is not yet finished. You repeat for the I equal to 3. Whereas I equal to 3, you have all this value to update in your calculation. When you do the same process, I will not show you because actually this one is same like this, just repetition. And when you do the same process, you got here, your y4 will be equal to 0.4312. Z4 will be equal to 0.0516 and our x4 will be equal to 1.0. So this is the important part here, because given in the question, okay, you have in the question boundary condition, which is y not equal to y not equal to 1.2 or x not equal to 0, and then you have y4 equal to 0.9 for your x4 equal to 1.0. That is, this one is given by y 1.0 equal to 0.9. This is the actual solution. But this one, what you get here, as I mentioned in the step-by-step, this is y for Euler method. Y for Euler method is 0.4312, not equal with this y from the question, okay, which is not equal with y at 1.0 from the question. That is, this one is 0.9. Means that we can say what we did all this, we got wrong solution. Why we got wrong solution? Because actually our z naught, the starting value of z, we just guess the value. The value is not necessarily correct because here we guess the value equal to negative 1.5, means that our z naught is not equal to this value. But class, it is okay to get the wrong solution here because you need the information from this step to find the actual z naught later. And then when this one is not correct, we need to repeat, okay, the same process, which is here. You need to find, okay, this is the next step. You need to find or guess new Z0. If you refer to the module, page 141, the new Z0 is equal to negative 1.0. So I will use the same value as given in the example. And then class, once we got this Z0, we will have a system now, which is our F1, X, Y, and Z equal to Z. And then we have F2, X, Y, and Z equal to 2Y. You already have X not equal to 0, Y not equal to 1.2 from question. Now we add this one as our additional Z not equal to negative 1.0. Maybe some of you ask the question, if in the final exam, is it you need to guess the value? No need to guess the value, because in final exam, this Z0 for the first guess and second guess will be given to you. If not, I need to mark a lot of means that solution. Okay, it will take time. So you will got the value of the first Z0 and also the second Z0 from the question. So class, once you have this one, again you have to repeat the same process, means that solving system by using Euler method. That is, you need to start with I equal to 0. You already have X not equal to 0, Y not equal to 1.2, and also Z not equal to negative 1.0. So here, when we do this one, means that we want to find here Y1, Z1, X1. That is, we use the formula of Euler method. It is Y naught plus H, F1, X naught, Y naught, Z naught. That is this one, Y naught in the question 1.2 plus H 0.25 multiplied by the first function is given by the Z. So we substitute with this value, which is multiplied by negative 1.0. When we solve this one, we'll got negative 0.4. And then we do for the Z1 here, so you will have Z0 plus H, but now function number 2, X0, Y0, Z0. So this one will be equal to our guess here, negative 1.0 plus 0.25 multiplied by your F2 function, that is 2Y. But Y here is 1.0, so 1.2, 2 times 1.2. When you solve this one class, you'll got 0.95. And then you have to repeat the same process to get Y2, X2 and Z2, Y3, X3 and Z3, and also the last one you will get Y4, which is Y4. The answer equal to here positive 0.993A, and your Z4 equal to 0.9344, your X4 equal to 1.0. Again, if we check this one, it is not equal to 0.9 from the question. This is from Euler method. It is not equal means that our Z0 here that we guess here, it is not correct. It will produce a wrong answer here. So what to do next? Next class, you don't have to guess another value of Z0, but you have to extrapolate. You have to do extrapolation by using the formula of Z0 equal to, we have the previous formula, which is G1 plus G2 minus G1 divided by R2 minus R1, which is time D minus R1. So here class, we know that our first guess, this G1 is our first guess, is negative 1.5. Our second guess here, this one is negative 1.0. Desired value that we required, actually it is from question, that is Y 1.0 equal to 0.9. The value of y that we required that is 0.9. So this one is 0.9. R1 actually y Euler method that you estimate using z not equal to negative 1.5. So this one you got equal to 0.4312, and then this R2, it is y Euler method by using negative 1.0. That is this one you got equal to 0.9938. Means that when we want to do extrapolation, it is equal to negative 1.5 plus negative 1.0 minus negative 1.5 divided by our R2 is 0.9938 minus 0.4312, and then desired value 0.9 minus 0.4312. When we solve this one class, you'll got the actual Z naught roughly equal to negative 1.0834. Class, please bear in mind that when you do numerical method, you will got run-off error because there is a, we call it truncation error in your solution, because you run off the solution up to certain decimal places. So in your final exam, make sure for the numerical method you use 4 decimal places in all calculations. Because we want to minimize run-off error. So now class, when we got this Z naught which is equal to this one, you will have a system now which is, we have our function f1 x, y, and z equal to z. And then we have function number 2 x, y, and z equal to 2y. Then we have here x not equal to 0, y not equal to 1.2. And then we have z naught from the extrapolation is negative 1.0834 with our h 0.25. Is it finished? It is not yet finished, class. You have to do Euler method again. Okay, this one what we got. So when we do Euler method, we start again with I equal to 0. We have x not equal to 0, y not equal to 1.2, and also z not equal to our extrapolation value 1.0834. When we solve this one, you have to use Euler method formula y1 equal to y naught plus h f x naught y naught z naught, that is, here we'll have got the answer. Okay, what we did here, this one y naught, use this value 1.2 plus 0.25h. Okay, multiply by this is function number 1 class, so multiply by this z is given by this value, so multiply by negative 1.0834. You'll have got this answer equal to 0.9292. And then you can do for Z1 by using Euler method formula, you will got negative 0.4834. And then you for this x1, which is x naught plus h, you will got 0.25. And then class, we repeat for I equal to 2, I equal to 3, and then I equal to I equal to 1, I equal to 2, and I equal to 3. When for this one, you got all this one you got x2, y2, and z2. This one you will got x3, y3, and z3. And this one you will got x4, y4, and z4. How to know that our solution is correct? We need to compare this y4 from Euler method, which is here when you use your extrapolation value of z naught, you will got your y for 0.9, and this is equal to y 1.0 from the equation, that is this one also 0.9. Means that when this approximate solution equal to the actual solution given in the equation, we can say that our z naught now is correct, and what we get the solution from here is all correct. Okay. In summary class, if you do the last step for this I means the iteration. Okay, this I actually 0. This is what is the value of x, y, and z. Means that when I 0, so you need to write x naught, y naught, z naught. Okay, because it's xi, yi, zi. Means that our value here for x naught 0, y naught 1.2, and z naught negative 1.0834. And then I equal to 1, so here is x1, y1, z1. So x1 0.25, here 0.9292, and then the last one negative 0.4834. 2, 3, and 4. So I equal to 2, you write here x2 0.5. I equal to 3, you write x3 here 0.75. And then the last one 1.0. When here 0.5, x 0.5, you got 0.8083. And then here negative 0.0188. And then when x equal to 0.75, which is for I equal to 3, your y3 is 0.8036, and then this one 0.3854, this one 0.9, okay, as we compare it is equal to the actual solution, and our z4 is 0.7872. What we did class actually, okay, if I plot, just get the idea. 0, we start the solution with 1.2. And then when 0.25, it decrease up to this value. 0.5 decrease, for example, this one 0.8. This is for y, okay, and this is x. And then for 0.75, okay, decrease. And then for 1.0, okay, this one 1.0, it increased slightly, okay, up to here. So when we connect all the points, we got the solution like this. Okay, this is the solution for y and x. Why here? Important to know. You need to understand what you want to compute. Actually, the value of, okay, what we want to compute is the value of y. Value of y and x. That actually is just to facilitate us to get this y. But the more important part is we want to compute the value of y and x, because we have in the question second derivative of y respect to x, which is equal to y. Okay, so we want to find what is y and also x. Okay, but we need this z to facilitate us to compute this y by using shooting method. So class, this is how you can solve a simple problem by using shooting method. I hope this explanation will help you to understand and to answer the assignment related to shooting method problem. Thank you class. If you should you have any problem, please do not hesitate to contact me.